Now we have to discuss the transistor crystal oscillator circuit. Okay, previously we have to discuss Hartley oscillator, Colpite oscillator, its working and its a frequency of oscillation we have discussed. So LC oscillator, RC oscillator has LC component and RC component in its tank circuit. The crystal oscillator, we have to discuss that crystal material, namely rochelle, salt, quartz, tourmaline exhibit piezoelectric effect. If AC voltage signal is applied across the plate, crystal will start vibrating at the frequency of applied voltage and produce a AC voltage. Such crystal which exhibits piezoelectric effect are called piezoelectric crystal or quartz. Most commonly used crystal because it is inexpensive, readily available in nature. So in order to use the crystal it exhibits the piezoelectric effect. If AC voltage is applied across the plate, the crystal will start vibrating at the frequency of applied voltage and producing AC voltage. In order to use crystal in electronic circuit, it is placed between two metal plates. The arrangement then form a capacitor with crystal as the dielectric. If AC voltage is applied across plate, crystal will start vibrating at frequency applied. If the frequency of applied voltage is made equal to the natural frequency of crystal, resonance takes place and crystal vibration reach a maximum value. This natural frequency is almost constant. The effect of temperature change can be eliminated by mounting the crystal in temperature control oven, as in radio and television. This natural frequency is almost constant. We already discussed the crystal equivalent circuit. Actually behaves as a series RLC circuit in parallel with CM, where CM is capacitance of mounting electrode. Because of presence of CM, the crystalline has a two resonance frequency. Crystalline has two resonance frequency. If in the conditions crystal impedance is very low. one of these in series frequency Fs in the condition crystal impedance is very locus. The other is in parallel resonance frequency Fe, which is due to parallel resonance of capacitance Cm and reactance of series circuit. In this case, crystal impedance is very high. Crystal oscillator are used whenever great stability is needed. For example, in communication transmitter and receiver, digital clock. The transistor crystal oscillator, it is similar to Colbit oscillator, except that in the feedback network the crystal is used in place of inductor. Crystal will act as a inductor from a parallel tuned circuit with C1 and C2. So it form a parallel tuned circuit with C1 and C2. The positive feedback is provided by the voltage capacitive voltage divider. We know already C amplifier, already we discussed its circuit working and all these things. R1 R2 potential dividing plus VCC is applied for the circuit. Here one switch is connected. Whenever switch is on, VCC voltage is applied to the C amplifier. So R is a bypassed resistor, stabilized resistor. C is the bypass capacitor. So bypass capacitor C is parallel with the RE. We have to connect. If emitter bypass capacitor, if it is not there, the amplified AC oscillation will drop RE across the RE. Thus the gain is reduced. Coupling capacitor is connected between input side and output. Cin is input capacitor, Cc is an output at the collector. So this coupling capacitor blocks the DC, allows the AC signal. So the part of the output voltage given back to the feedback network, that is C1 C2 in series with the crystal circuit. So RFC radio frequency choke is permit flow only DC signal current, block AC signal because of AC signal on the power line to affecting the output signal. In crystal oscillator circuit operation we have to discuss. So RFC provide the isolation between AC and DC operation. C in C are a coupling capacitor. So working, the phase shift of 180 is produced by transistor. Further phase shift of 180 is produced by capacitor voltage dividing network. The circuit will oscillate at frequency which lies between Fs and Fp. That is series resonance frequency and parallel resonance frequency, but close to parallel resonance frequency only. So circuit operation, in crystal oscillator, the crystal will act as an inductor here and form the parallel tuned and form the parallel tuned circuit with C1 and C2. C1 and C2. Positive feedback is provided by the capacitive voltage divider. Capacitive voltage divider. When power supply is on, it produces high frequency stability oscillation because in feedback network crystal is used. In feedback network crystal is used. Feedback network produces phase shift of 180. Further 180 is produced by transistor amplifier. So total phase shift is 360 between the input and output, which is necessary condition for maintaining sustained oscillations. Crystal has two resonance frequency. One of these is series resonance frequency Fs. In this condition, crystal impedance is very low. Other in parallel resonance frequency Fv, which is due to parallel resonance of capacitance Cm, reactance of series circuit. In this case, crystal impedance is very high. Series resonance frequency Fs is 1 by 2 pi. Series resonance frequency Fs equal to 1 by 2 pi under root Lc. Parallel resonance frequency 1 by 2 pi under root L Ct, where Ct is equal to 1 plus C by Cm. It appeared that Fe is higher than the Fs, but the two frequencies are very close to each other. It appears that Fe is higher than Fs, but two frequencies are very close to each other. It is due to that the fact that the ratio C by Cm is very useful, very small. To stabilize the frequency of an oscillator, crystal may be operated either its series or parallel resonance frequency. Crystal may be operated at either its series or parallel resonance frequency. Crystal may be operated at either series or parallel resonance. Advantages: they have high order of frequency stability. They have high order of frequency stability. Quality factor of crystal is very high. Q factor of the crystal may be high as 10,000 compared to about 100 of LC tank circuit. The frequency of crystal oscillator changes by less than 0.1% due to temperature and other changes. Hence, stability is very high. Disadvantage: they are fragile and consequently can only be used in low power circuit. Frequency of oscillation cannot be changed precisely because it is a fixed frequency oscillator. So that is a disadvantage of crystal oscillator. So disadvantage: they are fragile, consequently can only use a low power. Frequency of oscillation cannot be changed precisely because it is a fixed oscillator. So crystal will act as inductor and resonate with C1 and C2. So oscillation frequency lies between series and parallel resonance frequency. So positive feedback provided by voltage divider network capacitor voltage C1 C2. So C1 and C2 will charge and discharge through crystal, will develop the frequency oscillation, frequency of oscillations. That frequency of oscillation given to the base of Cc. So whenever we apply this at base, collector current also increase. That collector current again feedback to the tank circuit, so that whatever loss that occur in the tank circuit is overcome by the feedback. So this feedback signal will be energized the tank circuit. So continuous oscillation will be produced in the tank circuit. So we can get the desired frequency of oscillation. This is the working. So next is a merit and demerit of LC oscillators and RC oscillator. So merit, demerit. The tuned circuit oscillator are good for generating high frequency oscillations. So tuned circuit as the LC oscillator has advantages for high applications, and RC oscillator has good suitable for generating low frequency. So LC oscillator has two drawbacks. Firstly, they suffer from the frequency instability. Poor waveform. Second, they cannot be used for very low frequency because they become too much bulky and expensive. So why they are suffering instability means we have to use proper mounting to the inductor capacitor. So merit of RC is used for low frequency and circuit is simple. They cannot use it for generate very high frequencies. So we have discussed all the oscillator. There is some advantage and there is some disadvantage. But so there is a instability in oscillator of different crystal oscillator. So what is the reason for instability in oscillator? How we have to avoid this? Instability in oscillator? Reason for instability in oscillator we have to discuss is inherent variation of transistor parameter. So transistor parameter we already know, alpha, beta, gamma. These are the transistor parameter which are temperature dependent. All these are. Second condition is variation in supply voltage. So supply voltage we are applying VCC to the circuit. So this supply voltage are not constant at all the time. So supply voltage is not constant at the all the time. So this will causes the variation in the current. So we cannot get the required frequency if the some proper voltage is DC voltage is not applied to the oscillator. So there is a fluctuation in the frequency. Next, temperature variation. So this is a major disadvantage of any circuit in electronic circuit. Major disadvantage is temperature variations. You know that the electronic we have to maintain always room temperature, that is 27 degrees Celsius. If more than room temperature the temperature is crossed, if temperature crossed room temperature, the condition is what will happen. Electronics devices are very sensitive to the temperature, and whenever more temperature or higher than room temperature increases, sometime in summer we are getting the 50 degrees up to Celsius. This is a double of the room temperature nearly. So what will happen, the electronic component designed at a lower electronic component designed only for room temperature. So we have to maintain this room temperature with the help of ACs, but we don't have proper other AC facility in our laboratories. So what will happen in our laboratories, the component will get damaged quickly. So what is due to this, our electronic equipment is damaged. Every time we have to go for repairing the component, replacing the component, then only we get the output. Otherwise there is no output we are getting. Next is a variation in output load. So load variation is also come in parallel with our output of the circuit. If load varies every time, what will happen, this parallel combination will gives load effect to our circuit. So our original output has to be reduced due to the load effect, and we cannot maintain constant output. Next is inter-element capacitance and stray capacitance. We already discussed in the RC couple, transformer couple, direct couple. There is a capacitance exists due to the higher frequency, due to the higher as frequency increases, the capacitance across the junction exists. That is inter-element capacitance and stray capacitance. So this inter-element capacitance and stray capacitance can be avoided by with some other circuit, cascade combination. So the higher end at higher frequency, the gain is a constant, maintained by constant with the help of C and CB configurations. We already discussed in unit 2 multi-stage amplifier and all this. Next is a mechanical vibration. So mechanical vibration, we are taking an mechanical vibrations, overheating of component and device in the circuit. Overheating of component and device in the circuit, imperfect tapping of the coils. So overheating and device in the circuit. How the circuit is overheating? Whenever we are applying some voltage, there is a limit in the circuit. Whenever we are applying more input at the, like power amplifier, more input at the input side, we get the heat at the junctions because of higher current flow. So junction, there is a heat exit. This must be avoided, otherwise there is a thermal runaway across the junctions, and device circuit has to burn. That is a major problem. Another one is coil. We are winding, we have the so many winding in the inductor. So this winding must be properly done, and this winding must be tap, otherwise there is a leakage exists between the coils winding. So all this the very reason for instability of the oscillator. So fault in active device also causes the instability. So another is also improper biasing into the circuit, changes in component due to humidity. All these are reasons. So the frequency instability in oscillator can be avoided by taking the following measures. So remedies. What are the remedies? So so we already discussed the instability of oscillator. So all this instability can be taken care in the remedies. So first measure is so stability can be maintained. We must use the voltage variation can be overcome by using regulated power supply RPS. Regulated power supply. Frequency stability can be increased by using temperature compensation technique. Frequency stability can be increased by using temperature compensation technique. The loading effect can be minimized by using buffer stage with the oscillator. The loading effect can be minimized by using buffer stages with the oscillator. So we have to use the buffer. We already know what is the buffer. Amplifier is a common collector amplifier. Its output is same as its input voltage. So V naught by V is always 1 in this buffer amplifier. So it must be avoids the loading effect. So this circuit must be connected in the output. The effect of changes in inter-element capacitance can be neutralized by adding swapping capacitance across the offending element. Swapping capacitor has to be connected across this inter element so that it will cancel the capacitance effect due to the high frequency component which are existing at higher level, higher frequency. So that we have to reversely we have to connect this swapping capacitor. Frequency stability of oscillator can be increased by taking tank circuit of high quality, high Q. So high Q tank circuit has to be used across the parallel C amplifier, and a coil must be properly tapped. Without proper tapping, we cannot achieve the stability. So oscillator circuit must be isolated from source of mechanical vibrations. There is a so much of mechanical vibration that has to be maintained. Maintain correct biasing. We must maintain the biasing. The biasing is a major criteria to maintain the constant output. So we must use the shielding part to avoid the effect of humidity. Use negative temperature coefficient capacitor to prevent the warming effect. Stability can be improved by using temperature compensation technique. And we have to use a temperature controlled chamber or used to minimize temperature effect. That is, we maintain the AC in the room. Supply voltage variation can be used for by using RPS. So these are the remedies for the this oscillator, instability in oscillator. So now next topic is comparison between LC RC oscillators. Its comparisons. So here serial number 1 to up to 7. Second is a parameter, LC oscillator, RC oscillator. LC oscillator, RC oscillator. Output frequency which LC oscillator is high value, RC oscillator is low. We know already. Frequency stability, which is more, RC oscillator has a good stability, LC has low, because RC is a bulky component, lesser cost, that is the advantage. There is no winding in this RC, whereas L we have the winding, so proper tapping and all this has to be done. So frequency stability is low in the LC. Wave shape, LC has a pure wave shape is poor, RC has very good. The output voltage is more in LC and less in RC. The tank circuit made of inductor and capacitor in this LC oscillator. In the LC oscillator, here resistors and capacitor. RC oscillator has resistor and capacitor. Cost is high in LC, low. Application of LC oscillator is a radio receiver. RC oscillator is audio oscillator. Crystal oscillator has communication transmitter, communication receiver, computers, digital clock, RF generator. So LC generally used radio receiver and local oscillator, TV receiver as a local oscillator, RF generator, high frequency heating So high frequency applications. Now next topic, next chapter we have discussed is fifth chapter, varactor diode, that is special semiconductor devices. Special. So here so many special semiconductor devices we have: UJT, uh, UJT, unijunction transistor, varactor diode, also called varicap diode, photodiode, phototransistor, LED, MOSFET, LCD. These are the different specially made we have here. Special doping is here, special type. So special semiconductor device. In BJT we have the output collector current of the transistor is proportional to the input current flowing into the base terminal of the device, thereby making the bipolar transistor as a current operated device or current control device. The field effect FET is also there. Special semiconductor is applied to input terminal, voltage is applied to input, gate to control the current flowing through them, resulting output current being proportional to the input voltage. The control of current flowing in the channel is achieved by varying the voltage applied to the gate. That's why it is called voltage control device. As the operation relies on the electronic field, hence the name is field effect, generated by the input gate voltage, then the makes the field effect transistor as a voltage operated device or voltage control device. FET is a three-terminal device, unipolar semiconductor device that has very similar characteristic to those of the BJT. The high efficiency switching operation is speed. It has high input impedance, easy to fabricate ICs, cheaper. It is used in most electronic circuit application to replace their equivalent bipolar junction. So we have to discuss the FET depend only on the one type of charges carrier, either electron or holes. So called it is unipolar device. So it is called unipolar device. So we have to discuss the varactor diode, variable diode. So reverse bias PN junction diode can be compared to charge capacitor as shown in figure. This is the figure of this varactor diode circuit. So two PN junction. P junction is a one plate, and this N junction is a N type region is a plate 2. In between there is a, we know already, depletion region. In between there is a depletion region. In between that is called dielectric. So N type is a negative ion, P type has positive, P type has negative ion, N type has positive ions, will form a depletion regions. We are applying a reverse voltage. To diode. The depletion layer width will be increases. Hence, it form a parallel plate capacitor. In reverse bias, PN junction can be compared to charge capacitor. PN runs P and N region away from space charge region are essentially low resistance area due to high concentration of majority carrier. The space charge region, which is depleted of majority carrier, serve as a effective insulation between PN region. So PN junction act as a plate of capacitor, while space charge region act as a diode. The reverse bias PN junction, those effective capacitance whose value is given as CT is epsilon A by VD WD. CT is epsilon A by W. For epsilon is Greek letter epsilon, equal to permittivity of semiconductor material. A is area of junction, W is width of space charge region. The width of space charge region is approximately proportional to the square root of reverse bias voltage W VR. The area A and permittivity epsilon being constant, so we can write equation CT is 1 by under root VR. So junction diode, which act as a variable capacitor under changing reverse bias, is known as varactor diode. It is also called varicap, voltage variable capacitor, or semiconductor device that is widely used in electronic industry and used in many applications. Whereas voltage control device, voltage control variable capacitance is required. All ordinary PN junction diode changes their capacitance with reverse voltage, but some diode manufacturer especially which changes their capacitance with reverse bias. Manufacturer especially which changes capacitance with reverse voltage of capacity range. Varactor diode are available from 20 pico to 500 pico. For normal operation, varactor diode always reverse bias. Capacitance of varactor diode is found CT is epsilon A by WD. So working of varactor diode, when PN junction is formed, depletion layer is created in the junction area. Since when PN junction is formed, depletion layer is created in the junction area. Since there is no charge carrier within depletion region, that act as an insulator. P-type material with hole considered as a positive, as a majority carrier. N-type material with the electron charge majority carrier act as a charge plate. The diode may be considered as a capacitor with the N and P region forming oppositely charged plate with a depletion region between them act as a dielectric. The depletion region width is directly proportional to reverse voltage. CT is inversely proportional to reverse bias voltage. When reverse voltage across capacitor diode is increased, width of the depletion layer increases. The distance between the two plates of capacitor increases, therefore total junction capacitance CT of the junction decreases. On the other hand, if reverse voltage of diode is lowered, the width WD of depletion layer decreases, distance between two plates of capacitor decreases, so total junction capacitance CT is increases. This we have to end of this session. Next class we have to discuss its applications and equivalent circuit.